Hi, this is Alex Pault for PSDtv. Today I'm at the TT Electronics booth at Electronica, and I've got Steve Oxley here, and we're going to talk about resistors. Isn't that right? Welcome to the show.
Thank you very much.
Well, embedded design is never getting easier, so it's always nicer to have better components, and a lot of people tend to forget the passives, but passives are just as important as anything else on the board.
Absolutely, that's something I always have to tell people. Don't leave the selection of passive components till last.
Very, very good. Now, you've got a new series of current sense shunt resistors out, right?
We have indeed, yes. We've got, just here, LRM AP3920. So this is a surface mount, pick and place, reflowable part, capable of between 5 and 10 watts, depending on what type of substrate it's mounted onto, and ohmic values down to 200 microohms. So ideal for measuring high currents with a minimum of voltage drop or power dissipation.
Very nice. Well, and that's all important too, because a lot of people forget all of these things take up energy, cut cost efficiency, increase thermals.
Exactly, that's right, yes. So it's plus it's important to avoid having too large a voltage drop as well in many systems. If there's a low voltage line, you don't want to have too much of a voltage drop across it, because otherwise you're not supplying the correct voltage to whatever is being supplied.
Exactly. Now, Steve, were there other members of the family? Can you show me some other parts?
We're working on a larger size at the moment, which is will be the 5930 size, which should be launching soon. And then for the higher currents, we've got basically a custom design service with these e-beam welded shunt resistors. So they come in basically all shapes and sizes, with or without plating, with formed terminations, with the option of adding a voltage sense leads onto them. Ideally suited for energy metering applications, for high power motor drive applications, but also increasingly seeing applications in the automotive sector with HEV really starting to take off now.
Excellent. Now, you had mentioned they were e-beam welded. Is there a specific reason why they're e-beam welded, not regular welding?
Okay, so e-beam welding gives a number of advantages. Key among them is you get a very flat, smooth joint, which means that the parts, if necessary, can be placed onto a PCB and kind of reflowed as a connection method. Also, it means the minimum of heating of metal, because the electron beam is such a tight spot, 0.1 of a millimeter spot. You're really just melting the very edge of that metal, and so that's the minimum of disturbance to the resistance alloy, which means you've got a very stable resistor. With a minimum of heat treatment afterwards, you get a very good stable ohmic value.
You know, and that's one of the interesting things. I'm a bit of an ancient civilization guy. You know, talk about swords and forging and quenching and such. It's always interesting to hear, you know, you're talking about the same issues.
Exactly so. But with e-beam welding, it really is a precision technique for welding parts together. You're just melting the minimum of metal and heating the metal to the minimum extent, and that's why you don't need to do so much of the kind of stabilization of the metallurgy afterwards.
Well, that makes a lot of sense. You're not stressing the metal, so you don't have to de-stress it.
Exactly, that's right.
Very cool. Now, where can they find information on this online?
Okay, so our website is ttelectronics.com. TTelectronics, all one word, .com. If you look on there on the resistors pages of the website, so just look under resistors and you'll find information on our current sense resistors range.
Excellent. Now, Steve, before I let you go, do you have any words for our audience?
Just to reiterate what we said right at the beginning, that it's good to consider passive components for whatever application area early on in the design cycle, because it's not just an afterthought, it's a key component of the system.
Thank you so much, Steve. I really appreciate you taking the time at this very busy show to talk to me.
It is indeed, yes. Thank you very much.
The pleasure's mine. And I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you. Tell your friends. This is Alex Pault for Power Systems Design. Have a great day.